talk to. So first, let's understand information management tools. When we talk about information management tools, as we all know, the manufacturing process have been took a drastic change when industrial revolution took place. Earlier to that, there was not much information technology available. If it's available, also it was not applicable in the manufacturing units. But later, after industrial revolution, there is a rebellion change in the manufacturing process with regard to the information sharing process. So let's now first understand information management tool, that is product and process tools and barcode system. So if you just look at here on the screen, information management tools, product and process tools, and barcode system. See, manufacturing has evolved considerable change, and there was a drastic change in the manufacturing process during the industrial revolution. And in the current global age or competitive age, just manufacturing practice, which is having efficient, cost effective, and flexible. So because of the present competitive age, and it's very important for any organization to manufacture practice which is having lean, efficient, cost effective, and flexible. So is this possible through world class manufacturing? Yeah, and it's a collection of various concepts which will set a standard for the production and manufacturing for any organization to follow. Now, under that, the first thing which we are talking about the information technology, let us understand the concept of information technology. See, as we all know that business managers have will come across or face different challenges in the day-to-day carrying out the company's operations, and also while creating the information sharing system. So, the most one of the fundamental component in today's business environment is information technology. Why? Because it's a very important key feature in business management, because it includes both computerized data systems as well as communication functions. So, in order to get success and to have world class manufacturing in any organization, information technology should have a standard and should have set some standards in their organization. So, what's the need to manage information? As we all know that there is a tremendous growth and heterogeneous collections in the digital information, which will depends on different types of information management tools that will try to preserve, organize, and access information that is needed for the profession or to carry out professional task. Now, under that, we have the different points that are needed to manage the information, that is to save time, preserve information, and also to maintain integrity, to understand and use information. Means whatever the information they are collecting, that has to be
So if you look at here, we need the data or the management information to save the time, and whatever the information we are collecting, that has to be maintained, and it has to be maintained in such a way that it should be understandable and use information for the future purpose. And we have key technologies that are being used in the information technology or management information and how it is done. So let us see what are the different sources that are required or how they will maintain the information. If you can just have a glance over here, invention of mainframe computers, invention of mini computer, word processor, personal computer, development of computer network and linking of PCs and workstations to a central machine, development of LAN, linking individual groups of PCs together, often with a mini computer as a shared repository, and also development of WAN, that is wide area network, via satellite or landline, linking users in one network with information stored on a remote machine or with the users on that network. And also creation of optical storage device capable of mass storage of text and document images, and creation of document scanning technologies. And these are the different technologies that have been used for the storing the information that is used in the manufacturing process. Next, we have information management tools. And under this, we have, as we all have heard, CAD, that is computer aided design, computer aided engineering, computer aided process planning, product data management, and group technology. So these are different tools which are used by the management for storing the information about their organization or manufacturing concern or manufacturing process. And under that, we have lean production tools, like which are often dubbed as Japanese manufacturing techniques or just-in-time tools such as Kanban, statistical quality controls, that is SQC tools, barcoding systems, decision support, manufacturing resource planning, enterprise resource plan, that is ERP, MRP, MES, and SCM, that is supply chain management, and data warehousing or data mining. So these are different tools that are being used to store the information about the management and the processing. And under that, product and process design tools, we have CAD and CAE and product data management. These are the three different most important tools that are being used for any product designing or process designing. So under that, the first one is CAD or CAM, that is computer aided design and manufacturing. And the role of computers in this is, they will always have a positive impact on manufacturing engineering in many ways, such as like they gain the knowledge of mathematical, natural sciences, and by study, experience, and practice. So what happens in turn, with the help of the machine, they will try to control numerical control machines, and which were first introduced in the 1970s. That is called CNC, means computer numerical control machines. And these are classified into two groups. One is computer monitoring and control of all the manufacturing process. Next one is manufacturing support applications, which deal with preparations for actual manufacturing and post-mortem, means how actually it is taking place, and after this, how it will be taking place. Examples, and in any chemical process industry, number of process parameters will be monitored. And in the second category, the example would be like CAD, that is use of computers to develop geometric models for all the products, that is in 3D form. And CAE, it uses computers to support basic error checking, analysis, and optimization. And CAM, here the computers are used to generate software to develop the computer numerical control part programs for machining and other process operations. And if you can just look at here, we have advantages of CAD. That is, with the help of CAD, we can do the more faster and more accurate than the conventional methods. And under CAD, it is possible to manufacture various dimensions, attributes of drawing elements, and modifications of model, which is very easy under the or with the help of CAD. And packaging also is possible, and it is easy under, means 3D visualization can be done with the help of CAD. Next, we have CAP, that is computer-aided process planning. Under this, we use computers for designing physical products. And it goes along with the things like CAD, CAM, and it is like a link between the engineering and manufacturing process. And process planning can be actually, they have given a definition to us. Process planning can be defined as an act of preparing process documentation of manufacturing of a piece, part, or an assembly, etc. If process planning was done by using a computer, it is called computer-aided process planning. So whatever process planning is done, that has been done by using computer, then it is called as computer-aided process planning. So why we need a computer-aided process planning? What is the need? Because to understand the interaction between the parts, manufacturing quality, and cost, and systematically produce accurate and consistent process plans, reduce the cost and lead time of process planning. It requires skill requirements of process planners are reduced, increased productivity of process planner. And apart from this, we have a tools, different parts of SCAP are generative computer-aided process planning, variant computer-aided process planning, retrieval computer-aided process planning. Means these are the different parts of CAP with which they can have the database storage and they can create the geometry of the raw materials that are available and which are directly acting as an input for manufacturing process and manufacturing process parameters. Next, we have JIT, that is group technology, and it is an approach to organize manufacture which can be applied in any industry where small batch variety production is used. Very small batch we are producing, there it is applicable. And group technology is manufacturing philosophy or principle which basic concept is to identify and bring together the related or similar parts and process. Why? Because to take the advantage and similarities which exist or during all stages of design and manufacture. And you can just look at the GT layout, that is group technology layout. On the x-axis, they have explained as output or product variety, and y-axis, they have given as production or operations volume. And you can just see here, mass production type and batch type and job shop type. And there is a difference between production operations, that is flexibility, and production's operation capacity. And here it is job shop production system, batch production system, and mass. Means job means specific product only. Batch means similar. Mass means the higher quantity or the larger quantity. There it will be used, and use of group technology is to standardize and proprietary parts like nuts, bolts, screws, keys, washers, etc. And similar parts like shafts, gears, bearings, levers, etc. And product specific parts like gearbox. So if you can just look at here, standard and proprietary parts which are in maximum mass production is this one, that is nuts, bolts, screws, and key washers. And similar part, that is batch type, where same type of products will be produced, that is batch type. The shafts, gears, bearings, and levers. And job type means which are specific only to that particular product, that are called gearbox, bed, or saddle, etc. So these are three different groups where they can be able, means only smaller quantity it is useful, and this technology can be used with the help of an algorithm, and it will help the manufacturing unit to take or to tooling the facilitating quick changeover. Now next let us see the barcode systems. It is a technique for instantaneous acquisition of event data into computerized systems. Data is stored in the form of series of bars, means some lines will be given with white spaces, and based on the such standard, such as called the universal product code. And the key components of full-fledged bar coding system are the medium, that is an adhesive label, card or document on which the barcode symbol is printed. And printers, typically inkjet or laser printers are used. And scanners, these are optical devices, mostly handheld, consisting of an emitter, detector, and an optical lens. They extract the barcode data from a printed barcode symbol, and readers take data reconstructed by scanners and convert into some other usable forms such as ASCII text. So these are the different barcode systems that are available. So let us understand what is barcode. Barcode is nothing but a pattern of bars and spaces or varying with that represent digits, letters, or other punctuation symbols to identify an item or object. And barcode by itself is not a system, but an identification tool that provides an accurate and timely support of data requirement for sophisticated management systems. Barcode is predefined format of dark bars and white spaces. And on this, the actually it is in the form of binary code, that is ones and zeros, where it is designed that code on which the product data will be written and everything, the details will be done. And how barcodes work? Let us see how it works. The width of black bars usually represent the number 0 or 9. Sorry, 0 or 1. Well, the sequence of those bars signifies a number between 0 and 9. A computer connected to the scanner has all the information on what item is associated with that unique combination of bars and spaces, and it may add or multiply or divide those numbers to identify the correct product, which shows upon the screen. If you can just look at here. So this is start character and this is data message, this is digit and stop character. So this is how it is designed, and barcodes have a precise uniform way of scanner to read that and to transmit the encoded data to computer. And also you can see this manufacturer codes and product codes identifiers between number and check digits. So here we have quiet zone. Quiet zone, the empty space or empty or white space on the edges of a barcode is a quiet zone and is necessary for the scanner to read the label. Actually, to read that, we need a empty, that is quiet zone. And just look at here, in the picture. So this is called quiet zone, means after this bar, you can just look at, there is a space here. There is a space between the lines of this one and this space. So this is called quiet zone. Why? Because that is required to read the data. Otherwise, it cannot be read. And next we have number system digit. And you can see that number system digit, the first digit represents the product category on UPC code. For example, if you can see here, the 0, yes, or 1. And whereas means retail product. And if it is a pharmaceutical product, it will start with 3 and coupons with 5.
And you can just look at here, number system digit. The first digit represents the product category on UPC codes. For example, if it is a retail product, it starts with 0 or 1. And if it is a pharmaceutical product, it starts with 3 and coupons with 5. So, and manufacturer code, we have the separate thing. You can just look at here. The first group of characters, that initial number usually identifies the manufacturer, and manufacturer, that is GSI, and a global standards organization that regulates UPCs, and which will assign a unique manufacturer a unique code. And product code, you can just look at here in the image. You can just have a glance over here. So this is manufacturer code, and this is the product code. And we have check digit, which will confirm the accuracy of the data that is tied to the barcode. Is it right or wrong? And apart from this, we have benefits of barcodes. And means in what way this is beneficial, let us understand that. Because of barcodes, it's very clear, and often we can find the return on investment. Why? Because here there are certain key advantages such as accuracy, because barcode will always try to eliminate manual entry of product information, whether we are receiving, or is there an error, or it is in warehouse, or it is associated with simply swipe. So this helps us to find the accuracy of the product, and errors in barcodes themselves are extremely rare. Next one is real-time data. Here, each time an employee scans a barcode, and it immediately updates inventory and sales numbers in the company's enterprise resource planning or business management system. And this gives a business constant access to up-to-date data, allowing it to quickly calculate meaningful metrics like inventory turn, value of inventory on hand, or sales per week by item. And it also reduces training, that is reduced training, because for the most part, barcodes and scanners are self-explanatory. There is no need for any explanation. Why? Because once you scan it, you'll get the details of the product, who is the manufacturer, and what is his barcode given to the particular product. And whoever the new employees have been engaged in the organization will reduce, any training is not required. And it also controls the inventory management, because it reduces excessive spending on products. Employees can always find the most current information when reviewing inventory positions or trends in demand, which facilitates better decisions around purchasing and discounting. And we have next one is low cost. Even barcodes offer tremendous value, as the upfront investment is not large compared with that of comparable benefits. And with the help of barcodes, companies can create a limited number of barcodes for internal use of for price. Their needs grow, the cost of supporting technology remains reasonable. And these are the different use of barcode scanners. You can just look at here. These are handheld scanners. These two, the above one given to us, are the handheld scanners. These two are handheld scanners. And this one are connecting scanners. You just look at here, with are connected to the CPU. And these are different types of barcodes that are being displayed here. And for each barcode system, there is a different meaning. You can just look at here, types of barcode system. The first one is one-dimensional barcode. And here one-dimensional barcode represents data varying the width and spacing of parallel lines. You can just look at here. And this includes most of traditional or well-organized barcode types such as UPC and EN codes. And ID means, that is 1D means one-dimensional barcodes, or commonly referred to linear barcodes. And it has a limited number of characters, up to 8 to 15. Next one is matrix 2D. And matrix or 2D barcodes can store additional information, including quantity images and website URLs. And 2D barcode can render this information without any connection to the database. Common uses of barcode or QR codes, and which will have direct users to specific website or acting as digital boarding passes. Then just whenever we go to movies or some other product, they will scan, there will be scanner QR code will be given. Yes.
So this is how they get it scanned about the information. And there's a difference between 1D and 2D barcodes. 1D barcodes are having only horizontal or vertical lines, whereas 2D versions have both along with other shapes and patterns. So thus allows 2D barcodes to hold as many as 2000 characters they can hold, and compared with 80 characters with 1D code. In addition, a wide variety of scanners can read linear barcodes, while 2D barcodes require more advanced scanners or smartphones. Finally, here we can say that matrix barcodes can have smaller physical footprints than linear ones. So they are often ideal or small items with minimum space or barcode. And 9 common product codes we have under that, because companies are developing a number of different types of barcodes, because as they become widely used over the last 50 years, few of the most common types of barcodes are explained here. You can just look at here. The first one is UPC, that is universal product code, and it is used to label and scan consumer goods at the point of sale. It is all over the world. And UPCE is a smaller variation that encodes only 6 numerical digits. And UBC actually stands for Universal Product Code. And in the context of retail, the purpose of this barcode is to make it easy for users to identify specific product features. When an item is scanned at checkout, along with the making the checkout process are more efficient. That is, UPC code will help them to streamline inventory tracking, how much the stores it is there and how much it is at the warehouse. And UPC enables accurate and efficient product tracking all over the way through the production to distribution. And most of the UPCs have 12 digits, but some have only 7 digits. You can just look at your Universal Product Code. Next one is EAN, that is European Article Numerical Code. And this is international article number, and it is given to standardize describing a barcode symbology and numeric system in a global trade to identify specific retail product type. And apart from this, these are used. This is also used for labeling consumer goods worldwide for point of scale scanning, primarily in Europe. That is the reason European article number it is been called. And they look very similar to UPC codes, and the main distinction is the geographical application. And EAN consists of 13 digits, is the default form factor. You will find EAN 8, where space is limited, like small candies, there they use it. And the main advantage of EAN codes is their flexibility. And EAN 13 is high density barcode that can encode relatively large amount of data in smaller area. Next one is code 39. Code 39 is a barcode or code 3 of 9. It means are used to label goods across many industries and are often found in automotive industry and the US Department of Defense. It will enable us to use of both digits and characters. And it name originates in the fact that it could only code 39 characters. That is a name it is given, code 3 of 9. And the code 128 barcode, one limitation of 39 is relatively low data industry. However, 39 remains a popular and versatile choice. Next is code 128, which is written in ASCII. It is supported by ASCII only. Next one is ITF, interleaved 2 of 5. Means 2 out of 5 it will be. And it is used to label packing materials. This is for packing, and 120 is for logistics and transportation industries, and 2 of 5 is packing materials across the globe. Since they have deal with high printing tolerances, they are ideal for printing and corrugated cardboard. ITF barcode enables 14 numeric digits and use the full ASCII set. One of the greatest strength of interleaved 2 of 5 is that printed tolerances are suitable, and as a result, it will help us self-checking code is powerful tool for encoding information on product packaging. Next we have is Coda bar. Coda bar is no longer now leading type of barcode because one of the earlier barcode formats it is. And Coda bar codes may include any number of letters from A to D. And while no longer a leading type of barcode, or certain liabilities or certain libraries, blood banks and delivery services still use this type of Coda bar. And QR code, and nowadays everyone uses the QR code, at least everyone is familiar with this because new version of smartphones can read this barcode with built-in cameras. And Toyota invented QR code in 1994, and today they can be used to direct consumers to a website, confirm a person's key, identify a long login page, or encrypted data. And a QR code can encode more than 7,000 numbers or 4,000 letters. Next, we have PDF 417, and this is a 2D barcode that uses stacked linear rows and consists of anywhere from there to 90 rows, and each row is comparable. For a basic linear barcode, you can find PDF 417 barcodes on driver's licenses and other ID cards, as well as in warehouses. Next, we have data matrix. This is one other popular type of 2D barcode is data matrix. This barcode can store not just alphanumeric characters, but files. And data matrix barcodes have robust error checking capabilities, which allows scanners to still read those codes even when they have significant damage. So here we can say that a barcode can stand up to tough conditions, and it is often used on surgical tools, circuit boards, or electrical rating plates or appliances. Next, we move to the material requirement planning and manufacturing resource planning. So material requirement planning, that is MRP, and manufacturing resource planning is also MRP. So let us understand. Means till now we have understood the tools that are available for barcoding or different tools for designing a product. Now let us see what is manufacturing requirement planning and manufacturing resource planning. So if you just look at here, material requirement planning, it is a system for calculating the materials and components needed to manufacture product. See, if we, when you know, for example, if we take to produce any plastic bottle, or for example, take pen, whatever we write pen, if the pen is having cap, top, bottom, and the refill, to produce that product, what are the raw materials we require? We require plastic, ink, molds, and liquid ink. Yes, so we need cap, top, bottom, ink, and also the steel we require, because the nib, whatever is there available in pen. So these are the material that are required. So in order to have this material, how do we get that? How do we schedule the production purchase? How do we identify what are the additional ones that are needed for the production? And what are the material that are components that will go into the production purpose? That all will be understood here. So if you can just look at here, material requirement planning, that is meaning, scope, and objectives. So here material requirement planning system have become the most effective and widely used inventory control systems across the world. And the expanded MRP system becomes known as closed loop MRP, because it provides feedback from the execution function to the planning function. Means how to start till it is planned. So manufacturers could change plans when it becomes necessary. So all the MRP systems have been in existence almost 25 years. They had their share of problems and are both challenged and enhanced. And material requirement planning is a software based production planning and inventory control system that is used to manage manufacturing process. And it is having few components, inventory item needed to implement this schedule. In short, MRP is the scientific way of determining the requirements of raw materials, spares, components, and all other items required for production within the economic investment policies of the productive system. And MRP determines quantity and timing for material planning. MRP projects not only the demand, but also the timing of the inventory demand. Scope of MRP in manufacturing. So what is the scope that is there in MRP? That is manufacturing retail requirement planning. So here manufacturing organizations, whatever their products, face these same daily practical problems that customers want that products to be available in shorter time than it to take to make them. So here they have to make a decision whether they require the production or they have to manufacture the product. If they want to manufacture, what are the quantities that are required to manufacture, and what is the current requirement demand, and what is their future customer demand. And that all has to be done with the lowest possible cost. So that is the scope and objectives. We have inventory reduction, reduction in the manufacturing and delivery lead times, realistic delivery commitments, and increasing efficiency. These are the components of MRP system. You can just have a glance. It can be seen that from the figure, MRP systems has three major input components. The first one is inventory status file, material requirement planning processing logic, bill of materials. So under materials requirement, again we have order release requirements, order reschedule, and planned orders. Inputs to and output of MRP. So what are the inputs that are required and what is the output for the MRP? So inputs to MRP is under that supplier lead time. So here we are wanted to know what is the supplier lead time need to be essential part of how you plan production. And on-hand inventory means if resource material is available and there is no necessity to purchase new, and this will save their money and it will also optimize on the materials already which are there in the inventory, and it keeps promises of customers also on time. Next one is current forecasting. Here if there is any knowledge about what you have already done or forecasted, and this can be altered the organization to make changes that need to be made, and this will help to line up demand and inventory. Work and machine center capacity. Knowledge person capacity is must to do MRP, and whenever a customer wants material, we should make it available to the customer. Other one is order history and season. So there are some seasonal trends. As per that, the customer demands has to be met. And apart from the above things, even they have price trends of the materials, import policy of the government, and input files of MRP, that is master production schedule. So this is the part of production planning that will outline which products need to be manufactured and in which and what is the quantity has to be manufactured and when it has to be manufactured. And a master production schedule does not usually go into detail regarding the materials to be used in production. Employees assigned to task. Bill of materials. A bill of materials is a comprehensive inventory of the raw materials, assemblies, subassemblies, parts and components, as well as the quantities of each needed to manufacture the product. And to call it as a nutshell, it is a complete list of all the items that require to build a product. And bill of materials also includes the instructions for procuring and using the materials. And bill of material is sometimes referred to as a product structure, assembly component list, or production recipe, Next, bill of material structure. It is a hierarchical structure with the finished end product at the top, and it includes product codes, part descriptions, quantities, cost, and additional specifications. Amongst the most common methods of representing a BOM, that is bill of materials, are single level BOMs and multi-level ones. And we have core components such as priority analysis, part number, manufacturer name, part, phase, description, quantity, procurement, how much we are going to procure the material, what is its specification, what are the common things. Yes, this all has to be included in the components of BOM. And types of bill of materials are, we have three types, that are manufacturing bill of materials, MBOM, and EBOM, that is engineering bill of materials, and SBOM, sales bill of materials. These three are the different components of bill of materials, and this you can just have a product structure or bill of material structure of fire extinguisher, output of MRP, a planned order receipts, planned order release, order rescheduling, and MRP output reports. It includes order release notice to place order that have been planned by the MRP system, a report showing planned orders to be released in future periods, rescheduling notices indicating changes in due dates for open orders, cancellation notices indicating cancellation of open orders because of changes in the master schedule, reports on inventory status, and the outputs of the MRP system listed above are called primary outputs. And secondary reports, they are performance control reports, planning reports, exception reports. Requirements to apply MRP, that is all about the computer and necessary software programs to handle computations and maintain records. Next, we have requirements to apply MRP, and we have accurate and up-to-date master schedules, bill of materials and inventory records, integrity of file data. And what is MRP processing? How it actually takes place? We can just here look at the image that has been displayed in the form of a flow chart. Steps involved in MRP process. It starting with end items. The MRP process goes through the following steps. That is, establish gross requirements, determine net requirements by subtracting scheduled receipts and on-hand inventory from the gross requirements, time phase the net requirements, determine the planned order releases. Advantages and drawbacks of MRP: helps to minimize inventory level, increase the inventory turnover, track material requirements, means what are the material that are required for the production, and identify shortage in inventory items. It helps to track raw materials, work in process, and finished goods. It also helps to plan the procurement schedule, determines the most economical lot sizes for orders, computes quantities required for safety stock, calculate bill of material and assembles required on-time delivery, customer service responses. Drawbacks: with the above advantages, MRP also have several problems, under which we will try to understand two problems or two drawbacks that MRP has. Under that MRP only give accurate output if accurate input is provided. Whatever input you give, only you'll get that output. If you are giving wrong input, automatically you'll get the wrong output. So it depends on the what input you are giving to that. So if you are missing anything, then you are going to miss even the output also, whatever you wanted. And also another drawback is possibly encountered with MRP is costly, it is time consuming and difficult to implement. And many business, when trying to implement MRP, there is a resistance from the employees. They don't want to change. They want to be as it is. So that resistance also is not able to change the MRP, and this is one of the most important drawback. Next one is manufacturing resource planning. That was manufacturing retail requirement planning. This is resource planning. This was evolved in 1980s because manufacturers recognized the additional needs, that is expanding of MRP to involve other areas such as planning process and enable detailed capacity requirement plannings. And MRP is an integrated information system used by business, evolved from early materials, including the integration of the additional data such as employee and financial needs. And its system is designed to centralize, integrate, and process information for effective decision making in scheduling, design, engineering, inventory management, and cost control in manufacturing. Next, MRP1 versus MRP2. Here it is given the differentiation, capacity requirements planning, and the application of MRP2. So how it is applied, you can just look at here. This is business process, MRP, how it engineering data, customer order data. It goes through the different things, that is production planning, master production schedule, rough cut capacity planning, and material requirements planning. Under that we have capacity requirements planning, work order release, shop floor activities, purchase order release, purchase order status, labor and inventory accounting, financial operational control. And advantages and disadvantages of MRP2. Here advantages for maximum efficiency, production on a day-to-day basis, creates standards and provides guidelines. And disadvantages, we have risk in implementing, loss of productivity, and it's not suitable for all, and data accuracy risks. Next, we have enterprise resource planning. ERP, that is software and solutions used to streamline, automate all business process. And in general, ERP software is used to manage and integrate various processes of finance, human resource, supply chain, commerce, reporting, operations, manufacturing, and distribution. So manufacturing ERP system can be used and integrated into various business process. And key features of ERP system, we have inventory management, compliance and risk management, quality control, process automation, requirement planning and management, distribution and supply chain management, asset management, finance, and accounting. And who are the users of ERP systems? We have different, that is like essentially it is massive companies will use, which are essential to large sprawling organizations, small business, including independent retailers and services. We also find this type of service to provide valuable support. And different types of ERP. The first one is on-premise legacy ERP, and it is known as on-premise, or ERP is also known as legacy or monolithic ERPs, which are installed in the organization's hardware present at their facilities. Cloud-based ERPs. Cloud-based ERPs use the software as a service architecture and model where all the data storage and presenting power is installed at a single location. Next, hybrid ERP, it's a combination of both the things, that is cloud-based ERP solutions and address data security concerns. How ERP systems work. Next, we have advantages and disadvantages of ERP. Real examples of large companies using ERP, that is Amazon is using, Starbucks and Toyota. These are using the ERP, that is leading companies. These three leading companies are using ERP software used by them, and the areas in which they use that software is useful for their business purpose. And differences between MRP, MRP2 and ERP. And this is the difference between MRP, MRP2 and ERP. Next, we have just-in-time manufacturing. And when we talk about just-in-time manufacturing, let us understand how it has been evolved. Evolution and history of JIT, that is just-in-time, which has been developed by Toyota Motor Companies in 1950s. And in the post-World War II era, Japanese have focused on developing good manufacturing techniques to help them rebuild their economy. But in 1973, Toyota's systems attracted other Japanese companies, as Toyota shown huge profits, while most of other Japanese companies had experienced considerable losses. So they have learned this as an example, and they have studied these cases from the Toyota company. So here we have just-in-time concept, you can just look at your production, buffer, consumption, and demand. So this is the drawing of the JIT concept and the JIT versus traditional manufacturing. And under JRT, we have there are different methods. That is housekeeping, that is for physical organization and discipline, elimination of defects, setup production and flexible changeover approaches, small lot sizes, uniform plant load, leveling as a control mechanism, balanced flow, actively managing flow by limiting batch sizes, skill diversification, multifunctional workers, control by visibility using visual tools to improve communication, designing for process. Next, we have basic principles of JIT, and it has been observed these are the possible reasons for maintaining high risk in the stock, that are unreliable or unpredictable deliveries, poor quality from suppliers, increased variety of materials, quality at source, elimination of water, simplification, cellular manufacturing system, respect for people, and universal problem solving sequence also been given, under which we can understand the Kanban system. And it is kind of production which operates based on the information contained in cards called Kanban. So based on this, the theory has been made. An algorithm for JIT implementation is how they will implement the algorithm. That is management employees, ERP, check of the JIT, implementation of JIT, testing and control. And requirements for implementing JIT, that is just in time, reliable equipments, well-designed work cells, quality improvements, standards operations, full production, single piece flow. And advantage and disadvantage of adopting JIT, these are the different things. Next, components implementing JIT, that is Toyota is using, Apple, McDonald's, Harley Davidson, Indian automotive industry, JIT, that is just in time, JIT, Maruti Suzuki, Ashok Leyland. And so these are the different companies where they have been approached and they have been implementing. And companies in the Kanban system is Toyota, Spotify, Pixar, Apple, and Zara. So these are different types of JIT, that is just in time approaches given over here. And the next one is lean manufacturing process and application, that we will explain in the next class. So we'll continue in the next class. Thank you.